Marcos Garcia, Senior Cloud Architect, as you know me. I've been here before. Thank you for staying with us until this, like 7:30. It's a bit late. I hope you like the beer and the food. I'm gonna be quick about it. It's gonna be high level, not as technical, because honestly, Mohammed, you destroy my audience, man. Like OpenStack is hard. I don't know what I do. Please buy me over. I'm tired of working. Come on. No, seriously, OpenStack is hard, but it's good at the same time. Just imagine what if you had to write all that code by yourself, right? Obviously, Mohammed is finding edge cases that you could find with other commercial solutions. The difference is that it's open source, so you can always roll up your sleeves and see what's going on and spend a couple extra hours and figure out the root cause instead of waiting for your provider to answer by and tell you, well, we will fix it next release, right? You can always get to that level. And if you really don't like it, you get to travel to Boston. If you can pass the border, right, remember? You can get through the border and go to Boston and tell them, I don't like your product, and fix it, and eventually will be fixed. Or pay a company like Red Hat, or there are others present here that you can tell them, I want you to fix it. There are always a model, right? So let's see what happens when you want to do a cloud, but you still need to put the virtual machine somewhere. So that's the storage problem. So let's talk about Ceph. Why Ceph is the most popular backend for storage in terms of OpenStack. But I want to go today to a bit more broad use case and see what are the other options in order to justify the investment. You go to your manager and tell them, I want to get rid of EMC or NetApp. I want to put Ceph. Okay, but why? Right? So a couple reasons. You can find the economies of scale by using software-defined storage is that you can buy cheaper servers with cheaper hard drive, SSDs, and use that money to like invest in your human resources, in automation and management, and grow higher without being bound by the limits of your vendor, without being bound to the limits of the chassis. So you can just plug more servers without having to figure out how to fit in a chassis. But you will see there are other use cases that will make the investment better. And for that, as a kind of an inspiration, at least covered why the storage layer for OpenStack, we have this little book here that I invite you to download. It was written by Sebastian Hahn, which you may know already. He's a very prolific blogger, Red Hat employee, Innovance employee. He came to this office very often. And he and other people wrote a book, very quick one. I have it here downloaded if you want it in a USB, like 20 pages long. Basically, why Red Hat Storage, it's Ceph, basically. We just rebranded it, right? Inktank Ceph became Red Hat Storage. Why is it a good investment for you? But it doesn't address the other use cases. So if you're not successful justifying why Ceph for your private cloud with OpenStack, I'm gonna give you some ideas today, okay? By the way, this QR code is also on this slide. So this is what I'm gonna talk to you today. Bit refresher, for those who don't know Ceph, we did a talk maybe 3 years ago on Ceph, on our first meetup. But we're gonna cover a bit about hyperconverged. This is what Red Hat calls hyperconverged, which is very similar to what Mohammed mentioned earlier. Gonna show you some performance numbers. And then containerized Ceph, which is a cool feature and a cool thing that you can do now with Kubernetes, and Aidat can tell you how easy or hard that can be. But there is another approach to think about storage. Ceph for big data, this is the one I like the most. We are actively working in increasing the usefulness of having Ceph at your unified storage layer. You will see that later. And then what's coming technically with Ceph on the newer releases, Mimic and whatnot. You will see Illumos and Mimic. I've pulled some slides from the product manager, well, no, from the architect, the principal architect, Sash, that you may know. I put the link as well to his YouTube presentation in Boston. So I just cherry pick some of the content, things that I find pretty cool. The clicker, by the way, here, there you are. All right, so before I start, who knows Ceph? At least by name? Okay, I see plenty of hands. So you will laugh at me when I show you some basic slides, but I just want to go through a refresher. So there may be people who only know Ceph because of its role as a block storage for OpenStack. This would be this column here, which is the one that provides Cinder volumes and ephemeral volumes for storage VMs, so for OpenStack VMs. So when you boot a virtual machine, you need a hard drive to boot. There will be ephemeral from Ceph. The glance image would provide that through the RBD driver, and then Cinder would attach an extra volume if you want also through Ceph. Classical, quote-unquote, use case. Again, if you look at that book that I point you at, there's a bit more of an explanation of that use case. Object store is also a popular one if your workloads know how to work with object store. Otherwise, it's a bit limited for the OpenStack housekeeping task, like backing up the glance images. But if you were serious about having a big scale-out storage layer for your company, unstructured data and media files, multimedia and whatnot, you will find that this use case is actually growing in popularity, and I will go further in detail here with the S3 interfaces, because this is the pathway for big data of the next generation of big data solutions. Last but not least, the file system aspect of Ceph. Basically, NFS as a replacement for Hadoop as well, or as a dynamic file system as a service through OpenStack. More on that later. The architecture of Ceph, probably you may have seen this. Again, half of you know this by heart. These keywords here basically mean there are clients, so a software client that would connect to the cluster using multiple interfaces. The common library is called librados. If you connect through a HTTP interface, you go through the Rados gateway. If you connect through the RBD driver, which is the driver that glues a virtual machine with its block storage, that would be RBD. If you want to use a POSIX interface that understands what a folder is and a file is, and users and permissions and ACLs and whatnot, this would be CephFS. Underlying to it will be the Rados engine with all these crash algorithm that I will show you in a second. But basically, this is what I was referring. If you access Ceph through an object store, you have two layers of API, common gateway, Rados, and then the library to talk to the OSDs, which are the handlers of the hard drives. As Mohammed mentioned earlier, every hard drive should have its own software that owns the reads and writes. If you are not using JBOD, if you are trying to connect multiple hard drives to the same OSD, course ahead, you should try to do some tuning. Again, the recommended official strategy is to put one OSD per hard drive. Then you connect journals to SSDs and whatnot. Block devices, that's a bit less demanding if you ask me, because you are, sorry, that I was referring to block devices. Object store is a bit less demanding because you are going through an HTTP interface, kind of a slower interface. You are not accessing blocks on a 2 megabyte block level. You are talking objects, HTTP, longer timeouts. File system is kind of in between, and that's why the CephFS layer was forever in testing. With the latest release, Jewell, and Jewell is not latest. You will see that it was a year ago. It became stable. Yet another reference to another architectural component. The monitor nodes are the ones that handle the balancing of the workloads, as you may have heard in the past. The workers are kind of OSDs, as we call it. They have a file system in between the process and the hard drive. It's called the file system layer. Traditionally, XFS, X4, and or BTRFS, but most people use XFS. More on this later. I added this kind of useless slide because later, when I show you what's new, I will talk about Bluestore. And in Bluestore, you will see this architecture has changed. Now, again, this is from the OSDs. The monitor nodes, what they do is they orchestrate, if you want, the health of the cluster. They auto-balance and rebalance the crash map. About the crash map itself, this is the algorithm that allows Ceph to scale. This is the foundation of the software-defined storage, in which every component of the cluster knows where to write the data based on an algorithm. There is no single point of logic, I guess, in which every node of the cluster has to ask a central entity where to write the data or where the data is. All of the guys, all of the members of the cluster share an algorithm that routes, kind of a phone book, if you want, that routes every write and every read to its proper hard drive. Okay, it's an algorithm that distributes a workload, not a orchestrator, a single entity. There's no single point of failure. Everybody talks this language, and if you need to write to this object and you cannot find it here, you know where the replica is. By the way, the objects are by default replicated 3 times, although this is the replication algorithm. So when a client writes to one OSD, so the one that the algorithm told me you need to hit this OSD, the OSD will replicate the write to another OSD, like 2. This is the default behavior. Until you get the ACK, you will acknowledge back to the client. That makes you wonder, well, networking is critical, right? You need very fast networking, so this replication works well. There is another option I will show you in the next slide in which you can change this behavior and use Erasure coding, which uses yet another algorithm to handle the replication using less capacity. But anyways, the workflow, as I was saying earlier, the OSDs will take objects, like the request to write something, will translate it as a file, and the file will be put on a certain hard drive, right? That's why we need a file system. Again, with Bluestore, you will see this thing changes. As I said earlier, the Erasure encoding, it's a different way to replicate data on your cluster. So instead of having 3 copies, which is the default behavior in Ceph, in which you write on one and the replicator will move the data to 2 other locations for protection, with Erasure coding, you will have one write being acknowledged almost immediately, while the Erasure coding signature, the X and the Y, which is a 50% overhead, will be split through other blocks. Now, this actually is a bit more network intensive initially, because there are like, in this case, for one write, you will have like 6 blocks to be split for resiliency. But the thing is that at rest, as they call it, data at rest, it takes less space. Although it takes more CPU and more network through like as a peak bandwidth, it takes more, but the writes are faster as well. You get the acknowledgement faster. Most people don't look at the AC for the faster response because that's not, oftentimes that's not the bottleneck. The problem is the overall infrastructure that you need. Here you need, for every terabyte of data, you need to actually buy 3 terabytes of storage, whereas Erasure coding is only 1.5. Also on the recovery side, Erasure coding, it's a bit more expensive to recover because again, if you lose one block, let's say number 2, the system, in order to recover, needs to read from 1, 3, 4, X, and Y. So there are like 5 reads to recover one block. Whereas if the whole copy that is lost here, this file in this hard drive in this server is lost because the server is lost, these 2 guys will send one copy to a third server, like a recovery one, and that'd be it. So it's kind of easier to recover from the classical system. There are trade-offs, but you could also look at it from an economics of scale. You need to justify to put Ceph on your data center. This may be one way to justify it, although there are trade-offs, okay? But having half the footprint is definitely appealing. Next. There you are. Next. There you are. So I didn't want to go too deep into the architecture. Not by any means I'm a Ceph expert, but I do sell storage. I do tell people what are the use cases for it. And there are some areas that people kind of ignore. If you go with the story that Ceph is just the backend for us, for OpenStack, you're losing part of the story. So most people deploy web applications, e-commerce, CRMs, even ERPs. And those websites, they have assets like pictures, like JavaScript and whatnot. Traditionally in OpenStack, we were telling, as a best practice, use Swift, which is an S3 replacement, right? We were telling them, store your media files on this object storage, which is HTTP addressable. Just put the URL of your Swift store and make the client download it directly, bypassing your web server, so reducing the workload of your web server. That was kind of a far-fetched story, because that means having your own Swift cluster publicly available. With its own backend, by the way. Swift has no relationship whatsoever with Ceph. It has its own replication, its own storage. Ceph worked very hardly to have a alternative to Swift. That's called the Rados gateway that implements pretty much the same Swift syntax, as well as the S3 syntax. So if you have a web developer who knows how to store their static files on their website on S3 or on Swift, you can tell them, now you have a private cloud hosting for your media files that will reduce the burden of the workload on your web servers. You can bypass SSL, like who needs SSL for an image, right? And this would be the way in which the web application points to the S3 or Swift URL through the Rados gateway, and when the user needs that media to display the website, they can download it directly here. That would be the best solution. If you could only manage for your development guys to host the media in the Ceph object gateway, that's already a saving. Instead of having your own server with plenty of media files in it, and you're just bypassing that and use it as a central repository for media, that's already a win. This is kind of huge if you think about the amount of media file that companies are generating, like video recording, images, snapshots, inventory pictures, for ERPs. You could tell them you can save a lot of money by using this replicated software-defined storage instead of your traditional tier 1 NetApp EMC, okay? You don't need that as much protection if you want with those files. So this would be one way to sell internally a Ceph project. Another way, and the clicker doesn't work. There you are. Cold storage. You could leverage Ceph ability to do tiered storage and say, let's have one warm layer if you want, using SSD, very capable of absorbing changes and being very quick to write, very fast IOPS, and then replicate that to a backing pool with classical spindle hard drives. Okay, this is about cost. You could tell your manager, why am I investing all these NVMe or SSD storage files, storage servers, where I could put very long-lasting, like backup files or all media archives or all videos of security. I could put them on a backing pool. And this one doesn't need to be 3 times replicated. I could only put 1.5. So this is another way to save cost on your storage needs. And this one, we kind of went through that. I was assuming you guys were familiar with it, and that ebook that I pointed to you, it goes deeply into this use case and how to, why put Swift as a backend, actually not Swift, but the service, the Swift API, exposed through Rados Gateway, and RBD as a backend for all your OpenStack needs. Okay, that was kind of a 101, okay? Like, why Ceph? Well, will you care? As I told you, there are some definitely big cost savings advantages. I didn't go indeed into the management of storage. Honestly, I think even Saj mentions that the management of Ceph sometimes is a bit complicated. You would see later on the roadmap some new user interface that they just created for managing Ceph in production. Now, the hyperconverged one, it was funny that Mohammed mentioned it because I do truly believe that there are wins and losses. Okay, it's a bit more complex topology. There are some advantages and some disadvantages. So the first advantage of this hyperconverged, by the way, let me summarize what it is. I have a slide on this exactly, the following slide, but it's collocating the compute function with the storage function in OpenStack. So you have Nova, KVM, libvirt, Open vSwitch, and whatnot. This is a compute node, and at the same time, you have the Ceph OSD, okay, on that same physical node. And as Mohammed very well said, there is contention, there are CPU resources being fight upon. You should isolate resources, so I will show you that later. The main advantage why people look at HCI, it's, and by the way, it's not a full HCI. You look at Nutanix and others, they're kind of better thought of, they're much more converged. They also include some controller on it. We only handle the compute workload. So the HCI from not just Red Hat, like the OpenStack approach for HCI today, it's just a smaller footprint in which you have, let's say, 3 controllers, like that's what Galera and RabbitMQ requires. So you still need 3 controllers. And then you put the compute and the OSDs together. Whereas the classical reference architecture, that would involve 9 nodes. So 6 is better than 9 for starters. The moment you go bigger, the difference is not as impressive, okay? The other advantage is instead of standardization. What if you only had 1 server model? That'd be great for parts and replacement, for procurement, for discount management, right? That's kind of an ideal world, right? Because servers get discontinued and better servers appear with different form factors. But initially, for a greenfield deployment, that could be an advantage, probably for cost savings. Now, I wanted to show you what I was referring to. The bigger you go, the difference on the economies of converging both kind of blur. So imagine you had 6 servers, 6 VMs, and 6 hard drives, and you were splitting the topology like this. And if you go HCI, well, the laws of physics tells you were running top of maximum capacity. There's no way you can run more capacity, right? That makes sense. There's no free meal here. There's no free lunch, right? So the best thing you are doing is you're actually juggling things around. You may have 6 VMs, but 1 on each server. You may have 6 OSDs with 6 hard drives, but each one on its own server. Now, maybe because of how PCI buses work, how CPUs work, maybe this could be better, but maybe this could be better as well, depending on how the networking works, depending on how the bottlenecks are, and actually you get both. Sometimes it's better, sometimes it's worst. And we have some experiments that you can download on our reference architecture. It's right now OSP 10 Newton with Ceph Storage 2 version Jewell. You will see HCI is red, non-HCI is blue. You will see how pretty much they are up to par, in terms of IOPS. And the more VMs you request, it's linearly, so every VM gets their fair amount of IOPS. But eventually you hit a ceiling, and HCI is better. You may say, what? Better? Well, yes, because if the IOPS are all over the network, maybe you're hitting network bottlenecks, and you're better off writing locally without hitting the network than always going through the network, right? Here, all the IOPS are going through the network, one server to the other, whereas here, maybe some writes are local. That's better. But you could also see that, that non-ACI, in terms of throughput, could also be better when, for instance, you have small file reads. So basically, you have some cutoff points in which certain instances per server are equally, and on one is net, a net advantage, but there are other cases in which you see this little advantage of ACI, it goes as a disadvantage of a certain scale. Long story short, you should test it. There is no free meal here, okay? If you want to go ACI, look at it twice. There's a lot of tuning that needs to be done to avoid contention, and you will not create more performance unless certain profiles of IOPS are clearly identified. In this case, you should really do like host aggregates and do a specially tuned cluster. For more information, there is a URL here, but basically Google Red Hat OpenStack HCI or hyperconverge, and you will hit into this link. And they will tell you that part of that design that I showed you earlier is because the networking was done on purpose. They have its own networking for replication where there's no congestion in terms of network replication. That's important. We kind of trick you down on that. So if things go down and the cluster breaks and it starts replicating, a HCI mode could actually spread like a virus, and every member of the cluster could be suffering from network saturation. So we did that properly. We have dedicated networks for you see 10 gigabytes for storage. Just, you have to look at it and think seriously if you need this or not. Next, another cool thing that you may have not been aware of it is that we are working, and Sebastian Han is one of the guys working on it, on containerization of the Ceph components, the Ceph-Mgr, the Ceph-OSDs. And you may ask, why? Does anybody have a clue? Why would you containerize Ceph-OSD? Any volunteer? No? Irad? To run it anywhere, for instance? So this is one of the angles. Like, what if you were executing VMs on VexHost or on DigitalOcean? You wanted to have the same API, like with RBD or with Swift, or to write on your storage as you have today on your private cloud. You don't want to have different code for your data analytics, depending if you're executing on Amazon, on DigitalOcean, or on private cloud. So if you were to do big data analytics, and you have one single API to read or store your results, that you standardize on the S3 interface or the Rados, so Swift interface, you may want to deploy, let's say, an S3 interface on Azure. How crazy is that? I am on Azure. I want to write files using an S3 interface locally on an IP 10.10, on a local IP on Azure. Well, you could deploy on Azure a VM that runs Ceph. And that VM would store the objects locally until you finish your data crunching, and you can get out the result. So data analytics is the main driver, and we have the telcos asking for it because they're saying, I'm going to start private cloud NFV, but if I need to scale out during peak hour, I need to, do some machine learning for this customer. I may need to access capacity on a public cloud. I need the same storage offering. And until DigitalOcean or VexHost or Amazon offers a native Ceph interface, well, you kind of, somewhat with Cinder. But if you were to connect RBD like a SAN offering, until then, you could also deploy it yourself with containers. On-demand storage cluster will be this follow-up. You should be able to deploy it dynamically, right? So create the cluster with a single click in Kubernetes. Kubernetes will take care of the replication, of instantiating the monitors and the OSDs in the proper order. Way easier than with the current approach we did with Ansible and packages being installed manually. This is one way to make it faster and to launch clusters on demand. Yeah, go ahead.
Back to the slide, the previous slide. What do you mean by QoS?
Wait a second. The QoS point, it's about the C groups feature of containers. When you run a Docker file, you can say, this is your C group setting, this is how much RAM and CPU you can have. Eventually, Docker already kind of has that, but with Kubernetes, a bit of work in progress, correct me if I'm wrong, Irad, but the amount of granularity you can define for your C groups, how much CPUs you need, how much cache can you use, how much hard drive IOPS, how much network IOPS. That's with the C groups you want interface that is abstracted with containers. If you want to do that today with OSDs, Ceph OSDs, as root, you have to create a C groups policy, which is like Chinese, and you have to deploy manually, which is what we are doing today, by the way. On the HCI reference architecture, we have manual settings with C groups and policy kits and XML files on /etc, that you have to put in proper order. I mean, classical sysadmin stuff, but kind of hard to automate. So we're saying with containers, you have this standard interface in the Docker file that consumes C groups, and you could do CPU pinning in a better fashion. That kind of QoS. It doesn't mean that Ceph itself has a QoS, which it does, but it's a work in progress, a QoS feature per se. And this is kind of a topology of what Sebastian has been working for the last year and a half. You can see demos and videos on his blog. I will show you later. But he's using Kubernetes. He's deploying the monitors and the OSDs kind of in a distributed manner. So you have nodes with OSDs and monitors at the same time, which is funny because the Red Hat will not tell you ever deploy the monitors on the same nodes as the OSDs. As it's against best practice because of resource contention. Now, if your Docker file for the monitors and the OSDs have clear rules of engagement, you shall not take more than 2 CPUs, you shall not take more than 1 GB of RAM, then, okay, then you are guaranteeing some certain isolation so the monitors cannot be constrained, right? So this is what he's working on, and the networking, Flannel, it's overlay over overlay. So the performance is, depending on your deployment. He kind of has tested it in laptops and public clouds. If you were to test it on physical bare metal, the only ones I've seen is with Quanta servers, and it was for a POC. I haven't seen this in production. But as a source of inspiration, this is what's coming for you guys in the future, containerization of everything. Next slide. You think so? I think it just ran out of battery. And well, anyways, you can find here the recipes and the email for Sebastian and his blog where he's publishing all this stuff, okay? sebastian-han.fr. Okay, big data. I found this very cool. At Red Hat, somebody came from product engineering and told us, we have many customers wanting to use the same pool that you have on OpenStack, like as the common data layer for OpenStack, this cluster in your data center. We want to host big data workloads. We told them, well, use Sahara, put VMs and use Cinder as local storage. Well, they said, yeah, actually, you're asking me to run XDFS as a VM on top of shared storage. That doesn't work. You get crappy performance. Can you just give me a pool on your Ceph for a while? I will fill it up, right? Pull a bunch of numbers, do an average number, map reduce, and get the result. How many cars went through the highway today? You need 1 million samples and you just get one number. Map reduce, right? Give me access to that pool for a second. I will put all the data, dump it there, read it and process it, right? So they say, okay, let's go with this way. The traditional way you will see, it's this kind of copy information, process it, and get the result. The problem is when you have millions of data, millions of samples, you don't want to be moving that every day. You want to go like real time. The data is already there, and whenever I need it, I want to process it. So you will see that this is called analytics, real-time analytics. It's kind of fancier way to say real-time big data. And 451, sorry, dyslexia. They're saying this business intelligence and analytics, which is more real-time and applied big data, it's growing very fastly. CEOs are trying to find more information about their customers with this thing. So you could tell your managers that having Ceph as a common layer could allow you to do fancy big data at zero cost, in a sense. You're using capacity that you have already procured. And you are leveraging innovations in the big data ecosystem. For instance, as per today, after 2005, right? 2005, you saw Hadoop, but now 2015, 16, you will see Spark, you will see other real-time processing engines. And this is kind of, you can tell your manager, this is new. Like you didn't know because they didn't exist. Now there's new options. You can tell them to justify new experiments at home. So this second generation of big data and data lakes, it's an evolution from what we had in the past, where you had an inflow of data to an engine and it would create an output. And these are the three popular vendors. And they provide you both the analytics engine and the storage. So you had to come with your data, put it there on that cluster, XDFS or not, wait for it to be processed and then create an output. The problem with that, this ingest exit model, is that this batch processing has the data inside. You cannot read from elsewhere. And if you do, you will actually copy the data inside. So you cannot benefit from the big data benefits unless, well, this is what would happen. You eventually would have silos of separate information based with specialized analytics engines. Unless you have the same storage across engines, we're saying use Ceph, because you have multiple ways to get information in and out. So you have Ceph in between, which is already big. You have OpenStack on it. So put the excess capacity and connect Cloudera, Hortonworks, Mapper, Spark, Hive, Presto, connect to Ceph. With which interface? Well, there are many options. We're working with the S3 interface, as I said earlier. We're working on NFS, and we're working on ways to handle with data gravity. So the data is there. You don't have to move it around. You just have multiple ways to access the data. The same object can be accessed from Swift and S3 with the same number, or same ID, the same object ID. You will have an S3 URL and a Swift URL. They both reflect the same data. That would be the trick. So you don't have to handle data gravity. It's always there. You can, you see, we call it data lake. So the object storage will be the same layer. You also have VMs and whatnot, but you just leverage the economies of scale of your cluster. I use that extra capacity to connect your analytics through S3. And if you ever need to do ephemeral cluster, then you go back to square one, where you boot a VM, you create your own cluster, you put the data in, you process, you put the data out. That doesn't change. But for the next generation ones, you could do something like this. Again, S3A, there's the name of the API. They are also working on an NFS interface. They all resort to the Rados gateway or the CephFS components. So just keep an eye on this. Ceph is bringing many new features, and that's what I'm going to show you now, the roadmap. Okay, so in terms of, and this is my last section, and we will be quick about it. But I just pick a subsample of what SARS was showing in Boston, 2 weeks ago? You have a question? Using Ceph? Yes. What do you mean by fast? Like the IOPS? Mm-hmm. So the absolute performance you can get for IOPS through CephFS or Rados gateway is somewhat limited. It's not as fast as RBD. The reason is not just that the proxies are, were, at least until now, a bit of experimental. You will see now that SARS considers that fast enough and production ready. But secondly is the backend, because of that middle ground, the file system layer, but they are getting rid of that as per Luminous. So spring 2017, they are announcing the backend to be this high performance backend called Bluestore. So that has an immediate effect on all the front ends. So you guys were using Jewell. You have 2 releases until Luminous, which just appeared, right? But this is what the engineering team is calling like the release, because it has the performance benefits, which you didn't have in the past across all interfaces. Until now, it was kind of, yeah, you could do NFS, you could do CephFS, but as you were saying, it's not really fast. Now it is, okay? And they're saying, again, all claims from engineering, you should try it. But they bring the justification closer to you and your business case, in which the promise is there. Single layer, multiple ways of access, and kind of the same performance regardless of the interface. That will be cool, right? So the Bluestore is the engine that allows you to do so. It's a software, as you know, the OSD you can see, right? It's low level, and it will consume directly the block devices. So it's like direct memory access to the block device. No need to do file system writes, flashes, and all this crap with XFS, which is very good for multi-purpose, multi-user processes. But if you are the single process writing in a hard drive, you could directly write as if it was memory, right? So they're treating it that way. They're actually expanded to have its own metadata search engine. I don't think I explained it here, but they're also making search faster. So like your own cache layer, so you know you don't have to seek in the hard drive. You know already where the indexes are. They've done all that. Actually, they did it 1.5 years already, but they've been testing it at the scale for the last 1.5 years. I would love to test it, but it just appeared, and they're saying now it's ready for production. Smaller journals, compression, faster, two times performance on average. I don't know the details. I have the numbers though. So they say Bluestore with this tuned policy. It's the red line. You can see on average is twice as fast in terms of throughput, and EOPS as well for random writes. Okay, depending, it's across the board. It doesn't matter the block size, kind of linear. Again, you want to see more details, it's the presentation in Boston. The Ceph-Mgr thing is another improvement for management. You don't have to go as much to the command line. They're creating this website. The Ceph-Mgr is the command line version of the website, but under the hood, what it does, it talks to the monitor, and it does stuff that the monitor were doing in the past. So like what was doing it? The replication is still handled by the monitor, but this guy was taking care of the number of failure rates and all the statistics of the cluster. Now it's done by the Ceph-Mgr, not the monitor. New REST API, which replaces Calamari, and there was in the dashboard that I wanted to show you. You know the status of the cluster. Now it's the Ceph-Mgr, which does this polling, kind of a basic monitoring for you. So this is definitely a cool thing. Improvements, low-level stuff. The one I like, first that they have better. I heard Saz saying that we're already experimenting with RDMA. I never heard about it. I did hear about DPDK. Actually, they called it SPDK, if I remember properly. Extensions to DPDK to handle block writes. So they're doing this thing in collaboration with Intel, which will be yet another improvement of Bluestore. So imagine Bluestore as it is today, now with acceleration from the CPU and special instruction sets, thanks to DPDK and buffer processing and dedicated memory and all the performance features of DPDK, it will get better. Crash improvements, optimization for those who have multiple racks, in which you can have an unbalanced cluster. Like let's say you have 10 OSDs per rack and you add another rack with only one OSD. Until now it was a bit unfair and put extra workload on that fourth rack. You can say this rack is kind of new, like a junior guy, you know, let him be trained a bit. So this is with this feature, another improvement overall. Rados Gateway, the NFS Gateway is yet another feature, as I said earlier, because of the big data use case, as a way to dump data from legacy systems, you know, to just store the data there. I just got a clickstream registry from my old website. Just put the logs there. You know, just put it there, and somebody will analyze that later. This data lake analogy. Bucketing the sharding, I don't even know what that is. Inline compression, and the S3 APIs, which are almost there, all of them, they're just adding the encryption APIs on this latest release. And the Elasticsearch thing, I didn't get that much. If anybody understands that after watching the video, they're saying that you can DC chain metadata servers in Ceph and eventually reach an Elasticsearch that would index all the objects of your cluster, even though they may be tiered. So that was the use case, to search across multi-site deployments. So kind of a global view of all your objects in your cluster. CephFS, they say it's better. Now you have three of them at the same time. The performance of CephFS got better. They say it's production ready, so you can start using it on open bugs as a production code. And the last, what is the one I wanted to close with? This one. Huh? It's different things. I mean, Glacier is all files. Files here, files there, and it handles partition very well. CephFS versus Gluster, you mean? CephFS is still RBD and Rados based, so like partition is not like this preferred mode of working in split brain. Gluster is very good at that. You know, working offline, asynchronously replication, it's files. It's like rsync. It actually uses rsync under hood. So files to files is good. Now, if you want to change a consecutive, like 1 terabyte block, no. That Gluster doesn't work that way. Small files, media files, pictures, it works great. Gluster is very popular for big data as well, unless you do like, I don't know, big pieces of one single file. Smaller pieces, that works very well. That's a different story. I just wanted to close today's presentation with this. Are you aware that you can run Ceph on an ARM-based hard drive called smart drives? Who has heard about this? Just you? Okay. Yeah, there are demos, and Western Digital was demoing. They're already on the 3rd generation. So basically, hard drives with an Ethernet cable. You just plug the Ethernet, the Cat5, or I think it's just Cat5 at the moment, and that's an OSD for your cluster. It's pretty cool. I don't know the form factor, how you can put them all together, yet to see, but this is very cool, and we are actively working with partners to do so. just saying that in the future you may want to have a different data center layout. Just plug and play hard drives and just put more terabytes to your cluster. And that's almost it. I just want to tell you that June 20, you're all welcome to join us on the Red Hat Day. There's a registration link. Just put your name and your company name, and it will be a bit more fun